Okay, so on here we read the scenario up top, and so we wanted to fill in the table. So at 0 seconds, what did we get for the height of the penny? 1250. And for 2 seconds, we got... And for 4 seconds?
994.
6 seconds?
74.
And 8 seconds.
226.
So all we're doing here is plugging in a number for t, squaring it, multiplying it by -16, and adding 1250 to it. Do you agree?
Yeah.
Okay. So number 2 tells us to find the exact time t when the penny reaches the ground. So how am I going to do that?
Set h of t equals 0.
So h of t equal to 0. So I'm going to get 0 equals 1250 minus 16t squared. So what do we want to do first?
Subtract 1250 from the side.
Subtract 1250 from both sides. And we get negative 1250 equals negative 16t squared. Now what?
You can just divide by -1 to make it easy.
Divide by...
Change the signs, they're the same.
Okay, but I don't want to just do that. What else do I want to do with it?
Oh, divide by 16?
There we go.
Yeah.
Divide by negative 16. And so that gives me, when I do 1250 divided by 16, what do I get?
78.125.
Equals t squared. And then I would do what to get t by itself? Square root. And I would get that t equals 8 point something. 8.84. Is that good for the moment?
Yeah.
Approximately, we'll say. Okay, so it will hit the ground in approximately 8.84 seconds. So then number 3 says, find the average rate of change in the penny's height during the total length of its drop. Well, the total length means that I started at 0 and I was 1,250 feet off the ground, and I ended 8.84 seconds later when I was at 0 feet off the ground, correct? So 1250 minus 0 over 0 minus 8.84. I get 1250 divided by negative 8.84, which is approximately negative what?
Negative 141.4.
141.42, and these units would be feet per second because your outputs here are feet and your inputs are seconds. Do we agree with that so far?
Oh wait, that's like what we did on the delta map.
Yes.
Oh my god.
So all this is nothing of this is new so far.
Yeah.
We agree with that? Okay. So here is where it comes in. It says determine how many feet the penny fell during each second interval. So, what happens now? When I go from this interval to here, I'm adding how much? And from 2 to 4, I'm adding. And here I'm adding. So that's all even, right? But what happens when I go from here to here?
Minus 64.
Minus what?
64.
Minus 64. And what about from here to here? And there. So, determine how many feet the penny fell during each 2-second interval. Well, it fell 64 feet. And then it fell 192 feet, right? And then it fell 320 feet. And 448 feet. And it says, what do you notice? They are all even. What else do we notice? Are they the same?
No, they're increasing. So it's not a linear graph.
It's not a linear graph. What else do we notice about the numbers?
Oh wait, are they multiples of 8? Oh, wait,
Don't get that deep. Just look at the numbers and tell me, are they the same? And if they're not, what's happening to the numbers? How are they changing?
Wait, listen.
They're what?
Wait, hold on. I'll never find out.
Why is there... Okay, so look. Here there's a negative, and the reason there's a negative is because it's falling. Here, are they negative?
No.
Okay, so what do I notice for about 64 to 192 to 320 to 448? So it's falling faster or further every time, right? Okay, so the number of feet.
I felt so dumb.
You all were trying to give me a scientific answer. Fallen is increasing. Meaning that it is not constant. Well, if it's not constant, then we just said it's not a linear graph, and if it's not linear, then how do I figure out what it is? Well, that's when we go to the new thing, and the new thing today is, starting with number 5, complete the table with the average rate of change of the height of the penny. And it says the average rate of change of h over that interval. So, for number 5, this interval from 0 to 2 to include it is going to be, that's going to be my denominator, 0 minus 2. My output at 0 is 1,250 minus my output at 2 is 1186. And when I subtract those and divide by -2, I get negative what?
38. Wait, it is 32. Sorry, I'm not here.
Yes.
Back on question 4, they all got increased by 128 every time.
We're getting there. I'm glad you noticed that. We're getting to that part. Okay, so what do we get here?
Negative 32
-32
feet per second.
feet per second. Very good.
Wait.
And then for 2 to 4, we would be doing the same thing. 2 minus 4, which is 1186 minus 994, and that's going to give me, yes, Devin.
Aren't going back to the 0 and 2? Aren't you supposed to like
Flip those?
Yeah, I thought it was B
Yeah,
minus
because
A.
I thought it was.
It doesn't matter. So somebody asked me this earlier. Okay, if I do B minus A, then I have to do F of B minus F of A, correct? But if I do A minus B, I just have to make sure that I do F of A minus F of B.
Oh, okay. Yeah, that makes sense. It
As
does
long as
make
they
sense.
match.
Yeah, it doesn't match each other. Yeah, it makes sense.
So I like to call it parallel. Like if A is on bottom, F of A has to be right above it. So no matter where I put A and F of A, they just have to either both come first or both come second. Okay, so for 2 to 4, what do we get?
Negative 96.
Negative 96. Okay, do 4, 6, and 6, 8. So for 4 to 6, we get
Negative 160.
negative 160. And from 6 to 8, we get negative 224. Of course, all of that's feet per second, correct? Okay. So 6, we're going to get back to Amari's discovery in a minute. 6 says, is the penny speeding up, slowing down, or falling at a constant rate? It's what? It's speeding up. Because it's going from negative, well, the negative, what does the negative tell me? It's going down. You don't have a negative speed, right? It's just telling you the direction. So I'm going from 32 feet per second, which is not very much, to in the same time, 96, to then I'm covering 160 feet, and then I'm covering 224 feet. So in order you to cover more footage, that means the speed is increasing. So the penny is speeding up, and it says, how do you know? Well, the average rates of change over each interval are getting more negative. Now we say more negative because you can't say larger, because a bigger negative number does not mean it's larger. It's farther away than from 0, right? And it's really actually smaller. So more negative, which implies a faster rate. So if I have a faster rate, what kind of rate do I have for a line? A constant rate. So if I have a faster rate, I know that I don't have a line, but how do I know what do I have? Well, this is when we go to what Amari said, and in order to get up here, to go from one interval to the next, I was adding or subtracting 64, then I subtracted 192, then I did 320. But if I look down here, how do I get from negative 32 to negative 96?
Multiply it by 3.
Not multiply.
Minus 64.
You add 64. And what about from negative 96 to negative 160?
Another 64.
You add 64. And from negative 160 to negative 224, you add 64. And so what happens here is when it's linear, we say that your first difference is constant. And when your second difference is constant, then you have a quadratic. And when your third difference is constant, you have a cubic. And when your fourth distance is constant, you have a quartic. And so you will hear on tests and quizzes that a linear function talks about rate of change. In a linear function, does my rate of change change? No, it's constant. If you don't have a linear function, you will hear them talk about the average rate of change. And that is because they are talking about a specific rate of change on an interval. So that's the difference. Is if it's a rate of change, it's on a linear function. If it's an average rate of change, it's on an interval where I'm telling you the input is 0 to the next input, which is 5. Tell me what that average rate of change is. Okay? So, number 7 would want us to graph this. If I'm graphing, I'm just graphing 0 and 1250, 2 and 1186, 4 and 994,
Lauren McCoy, please come to Ms. Beverly's desk.
6
Lauren
and
McCoy,
674,
please come to Ms. Beverly's desk.
and 8 and 226. And what they're wanting you to see is clearly this is not linear, right? It's not the best graph either. Okay, turning over, going to your learning targets. So we have learning target number 1. And it tells us that quadratic functions have a constant second difference. Meaning the change over each interval grows or declines linearly. That's not my favorite word. So when it talks about a constant difference, I'm going to flip this over. I'll come back to it, okay? When it talks about a constant difference, Amari said earlier that all of these are increasing by what? By 128. Okay? So this was your first difference. When I get these numbers right here and I subtract them or add them or whatever you want to do to them, these are your second difference by increasing by 128 every time. Okay? So that's your second difference. And then learning target number 2, it says that the average rate of change takes the change in the output and divides by the change in input for a per unit measure. So then also remembering, like it said before, that the average rate of change grows or declines linearly. That's a horrible word.
Linearly?
Yeah. And the change in average rate of change is constant.
The change in what was constant?
Average rate of change.
016.
97.
Oh no, let it refresh again.
Why is it 2?
067 636.
Okay, so check your understanding. The quadratic function y equals f of x is shown. Find the average rate of change of f on each of the following intervals. So this is the exact same thing you did on Delta Math. So if I go here for -1, these are going to be my inputs. We're going to go on bottom. Do you want me to do 0 first or -1 first?
Doesn't matter.
-1 first. So -1 minus 0, right? So for -1, my output is 14. And for 0, my output is 7. So then 14 minus 7 is divided by -1 minus 0 is, there we go, -7. And then I would keep going on and on. So you all keep going on and on. I'm going to keep doing them too, but I want to make sure that you all know how to do it also. 0.
Oh, Miss Taylor. Just say that.
Did I do that? If we do say that in this class.
Doctor says
I have
Okay, from 3 to 4, what do I get?
1.
From 4 to 5? 5 to 6? What'd you say? And 6 to 7. There we go. For B, it says find the rate of change of the average rates of change. So I take the first two, and I'm going to do -7 minus -5, and what do I get?
Wait.
Try again.
Oh, wait, I flipped to
Wait, hold on, what was it?
negative 2.
-2. So it's wanting me to find the average rates of change of this. So this minus this, or this minus, whichever way you want to go, right?
But it's positive, right?
It would be positive if I went the other way, yes. So if I did -5 minus a -7, what would I do? I would get a +2, correct? Okay, and then if I did it the other, if I did -3 minus -5, I would get 2. And if I kept going -1 minus -3, I would get a 2. So that's my second difference. So therefore, because these all equal 2, and that's my second time, then therefore it would be a quadratic.
I don't get what I mean by the second one.
So how you're normally going to have it, side note, okay? So if I were to have this on a chart, which will be on your test, quiz, whatever I have, I would say -1 and 14, because that's the ordered pair, right? 0 and 7 is a pair. 1 and 2 is a pair. 2 and -1, I think, is the ordered pair. 3 and -2. 1 and 2, 2, yeah, 3 and -2. 4 and -1, right? And so if I was wanting to determine whether this was linear or quadratic, this table's not given to you. Like, I'm getting this from these points.
Oh my goodness.
These are these ordered pairs. Okay?
Yes, I see that.
So this, I'm adding 1, adding 1, adding 1, adding 1. Yes? So, okay, the left side checks off. They're all the same in between, correct? Well, over here, 14 to 7, I had to subtract 7, and here I had to subtract 5, and here I had to subtract 3, and here I had to subtract 1, and here I had to add 1. Do you agree?
So that's 1.
That's the one difference. But if I go the next time, how do I get from -7 to -5? I do +2, +2, +2, and +2.
So that's the second one.
Yes.
I wasn't even paying attention to that.
It's because they write it all crazy.
I got it now.
So if it was the same here, it would be a linear function. If it's the same on the second time, it is a quadratic. If that was not the same, I would go again. If it became the same, it would be a cubic.
That makes so much more sense.
If it's not cubic and I would go again, you could go on and on to find out what it is. Okay? Better?
Yes.
Okay. We're not doing C. We'll come back to C. For number 2, it gave us selected values. Now ours is this way, theirs is this way, right? Okay. And so here's all my inputs, and it only gave me some outputs. But by that knowledge, I can fill this in. So I do not know I do know that to get from -8 to -4, I did what? I add 4, and to get from -4 to 0, and from 0 to 4, so we're all good right here, yes? We know that the whole time my interval is the same. So therefore, all of these down here should be as well.
On the end, it's 16 to 18.
On the end from 16 to 18, which is only 2, right? So we're going to have to figure that out, yes? By dividing. We'll divide it eventually. Yeah. Yeah. Okay. So, how did I get from 24 to 31? Plus 7. And then, how did I get from 31 to 35? Plus 4. And that's the only real thing I have, right? So then I would say, okay, well, how did I get from 7 to 4? Minus 3. So now I either have to take this information and go all forwards with it and all backwards to fill in. So I do not know what I'm going to do from 35 to whatever, but I do know that from 4 to get to the next number, I'm going to do what? Subtract 3. So 4 minus 3 is 1. So 35 plus 1 gives me 36. And again, I don't know what I'm going to add here. However, I do know that to get from 1 to whatever, I'm going to subtract 3. So 1 minus 3 gives me negative 2. So therefore, 36 minus 2 gives me 34. I'm recording. Okay, so then I'm going to go backwards. And I don't know what I have to do here, right? But I do know that from here to here that I subtracted 3. But if I'm going backwards, what would I be doing? Adding 3. So 7 plus 3 would give me 10. So therefore 24 minus 10 would give me 34. Not 34. No, 34 minus 10 is 14. Yeah. Now they would want this to, they really wanted this to be 20. So if that was 20, this would be, I would do negative 2 minus 3, which would give me negative 5. So 34 minus 5 would give me 29. There will be a problem like this either on your quiz or test. No ifs, ands, or buts. Your homework for tonight, though, is the next page. And that is building a library. So, you're given the function. There happen to be linear, absolute value, quadratic, cubic, a square root, and a rational. So for the first one, I know if you want to use Desmos or you want to use a calculator, that's fine. Do so. I'm okay with that. But it's a line. A line is 0, 0, 1, 1, 2, 2, right? So I would graph this. If I don't know any points, what are our 5 magic points?
0, 1, 2, 3, 4, 5.
Or negative 2, negative 1, right? You start at negative 2 and you go to 2. I don't care what points you use. Negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1. Sounds great. Yep. Okay, your domain is from left to right. What's my domain here? You can
positive there?
There you go. Negative infinity to positive infinity, or you can label it as all real numbers.
Oh, yeah.
My range is from bottom to top, which is
Negative infinity and positive infinity. All real numbers.
or all real numbers. My x-intercept,
The origin.
the origin. So you can either put 0 or you can label it as just 0, 0 and actually give me the ordered pair. For y is the same thing, right? Again, I like doing ordered pairs. For your y-intercept, your x would be 0. For your x-intercept, your y would be 0. When am I increasing?
Negative infinity, positive infinity.
I'm always going up the hill, correct? Am I ever going down the hill?
Not in this one.
No. So that took us, what, 2 minutes? If you need to use Desmos to see that, that is fine. However, I want the next 5 to be done when you come to class tomorrow.